and you listen for a little while. The only difference between multiplying and dividing. So when you divide, what do we do when we divide fractions? Flip the second one over and it's a multiplication problem. Okay, so if y'all don't mind, if it won't throw you off, I'm going to factor and flip at the same time. Is that okay? No? Okay. All right. I won't do it. Okay. I won't do it. I will flip first. Okay. I will flip first. 4x minus 6 over x minus 1 squared times, flip the second one over. I don't change anything other than I'm flipping it over. And it becomes a multiplication problem. Okay, dividing by a fraction is the same as multiplying by its reciprocal. Now, it's just what we were doing before. Factoring and simplifying. Simple, right? So, 4x minus 6, GCF of 2, 2x minus 3. Well, I'm just going to keep going across my numerator here. X squared plus 2x minus 3, that would be x plus 3 times x minus 1. Denominator, x minus 1. I'm going to do this just to make things look a little bit more clear. X minus 1 squared is x minus 1 times x minus 1. So I'm just going to write that out so it's a little bit more clear when I'm canceling things. And then we have a GCF of x out of the 2x squared minus 3x. So we can cancel 2x minus 3 and 1 of the x minus 1s. So we've got 2 times x plus 3 in the numerator. And we've got x times x minus 1 in the denominator. Leave it in factored form. It's more useful in factored form if there was something else we were going to have to do with it. Don't multiply it back out. Okay? All right. So, here's another one. Y squared minus y minus 6 over y squared plus 6y plus 9 divided by y squared minus 4 over y plus 3. Okay, y'all don't want me to skip any steps, so we will flip. Turn it into multiplication. Then we will factor. If you personally can flip and factor at the same time, go for it. Just be careful. Okay, so first one, y minus 3 times y plus 2. Second numerator, nothing to factor because it's a linear factor already. First denominator, y plus 3 times y plus 3. Second denominator, y plus 2 times y minus 2. Here is a lovely example of why you must be careful with your signs. Okay, if you mess up your signs when you're factoring this first numerator, if you flipped that plus and that minus, you're going to end up canceling the wrong factors. Okay. Or if you forget on the difference of perfect squares that one gets a plus and one gets a minus, that's going to throw things off. All right, so we can cancel one of the y plus 3s, we can cancel the y plus 2, and that's it. Y minus 3 in the numerator, y plus 3, y minus 2 in the denominator. Okay, so be very, very, very careful with your signs. do one that doesn't have any numbers. Just variables. X's and Y's. X plus y over x cubed minus x squared divided by x squared minus y squared over x squared minus x. So, turn it into multiplication, flip the second one over. And let's start factoring. First numerator, nothing to factor, just x plus y. Second numerator, we take out an x, leaves us with x minus 1. First denominator, what can we take out? X squared. Leaves us with x minus 1. X squared minus y squared is x plus y times x minus y. Difference of perfect squares. I believe that puts us at fully factored, so x plus y in the top and the bottom, x minus 1 in the top and the bottom. X over x squared, we can cancel one of those. So that leaves us with an x in the bottom, a 1 in the top, and our x minus y is still in the bottom. Okay. We are. Are we going to get our first win tonight, tomorrow, Gabe? All right. I like beating Easter. Yeah. Okay, one more. X squared minus 2x minus 63 over x plus 1 divided by 9 minus x over x squared minus 1. I thought I heard something. I didn't know. All right. So, first numerator, x squared minus 2x minus 63, x minus 9 times x plus 7. Second numerator, take out an x, x times x minus 1. X plus 1 in the denominator, can't do anything with it. Second denominator. Typically, we don't do anything with linear factors, but look, it's really similar to what I already have in the numerator. We can factor out a -1 and change those signs. So the x becomes positive and the 9 becomes negative, so that we can then cancel out our x minus 9s. And in this case, that's all we can cancel out. But I think I preached this to you the other day. Don't leave a negative like that in the denominator. So I'm going to slide the negative up with that x in the numerator. Okay, now if that were a -2, the 2 would have to stay, but the negative sign we can put in the numerator. Okay, does that make sense? If that were a -2 that we had factored out, the 2 would stay in the denominator, but just the negative sign, we can move it to the numerator. Okay? All right, let's